Let's move on to the graphs of the sine and cosine functions. So you know every function, x squared, parabola, x cubed, look like that, linear line. So we wonder what the graphs of these functions look like. We've been finding the values based off the unit circle, but that's not graphing. And so what we want to do is figure out the connection between this unit circle and then the actual graph. So what I've done is I've picked some values of x, okay, and of course values that are on my unit circle. You can see pi over 6, pi over 2, 5 pi over 6. And then I plug them into my function. So in other words, the first one here, with my pencil, this first one, there it is, right, is going to be the sine of 0. All right, so the sine of 0. Remember that we're looking at the y values, so it would be 0. So my first point would be 0, 0. Then I find the sine of pi over 6, which is my y value, so that would be 1/2. So I would have a point at pi over 6, 1/2. Next, sine of pi over 2 would be 1. So pi over 2, 1. Sine of 5 pi over 6, rock chair. So that would be 1/2. So at 5 pi over 6, my y value is 1/2. Sine of pi, I mean, this is just good practice reading our unit circle here. Sine of pi, almost hit it with the arrow there, would be 0. So this would be pi 0. Sine of 7 pi over 6, looks like that's -1/2, -1/2. So 7 pi over 6, -1/2. Then the sine of 3 pi over 2. Where are you at, right chair? So my y value would be -1. So 3 pi over 2, -1. The sine of 11 pi over 6. Right chair, -1/2, -1/2. So 11 pi over 6, -1/2. And then finally 2 pi, I'm back at 0. So sine of 2 pi went all the way around. So 2 pi would be at 0. And if you remember, we said that you go through sine a period is 2 pi. So you're back at the beginning. So now what I want to do is plot these points. So I can come here and I can plot 0, 0. Got it? Let's call each one of these a half. So now I'm going to plot pi over 6. So we'll call this one pi over 6 and a half. Then I'm going to plot pi over 2 and 1. Then I'm going to plot 5 pi over 6 and 1/2. Pi 0. 7 pi over 6, -1/2. 3 pi over 2, -1. Go back up to -1/2, and then here. So as you can see, my x-axis is actually my angles, right? So those are my pi over 6, pi over 2, and all that good stuff. And my y is the value of my function, okay, my sine function, because that's my y values. So what I could do here is I could connect the dots and see that that's what, oops, missed that one, make the dot bigger, right? That's what a sine function looks like. Now, if you remember, we said that the sine function was an odd function, so I can actually, if I didn't want to read all of these over again and go in the negative direction of my angles, I actually can plot these points like these, and then back down, and this would give me the full graph. Each missing a bunch of those points, ain't I? This would give me the full graph from negative 2 pi to 2 pi. So that's what the graph of the sine function. That's why they typically call these sine waves. All right, and so by plotting the points, that's what it looks like. And then I can remind myself of all the different properties, the domain, all real numbers because it's y values. The range, if I go back here, you can see the highest that it went was +1, the lowest it went was -1. The sine is an odd function, so it's symmetrical, as I was mentioning here with the origin, so I can just copy all of those points. The sine function is periodic with period 2 pi. That means wherever you start, when you go 2 pi, you're back where you started. Where I'm at, the x-intercepts are -2 pi, -pi, 0 pi, 2 pi. So notice -2 pi, -pi, 0 pi, 2 pi are my x-intercepts. The maximum values of 1 and then the min values of -1. Once again, you can see here by my graph, my 1 maximum values and then my minimum values of -1. So nice little properties, and it's a good little practice to go through and draw this once so you can understand the connection between looking at the unit circle and turning it in to a plot like this. All right, if you remember transformations, do you remember transformations? A little bit. If I want to graph something like this function, so notice that I already understood how to graph the sine. That's this one, a lot prettier than mine, right? And so this is the graph of just the sine, y equals sine of x. If I multiply my y values, every y value by 3, that's what I'm doing here. So you can look at the second values become a multiple of 3. So 1 becomes 3, -1 becomes -3. Then you can see that this is a vertical stretch. Again, if you kind of sort of remember transformations, vertical stretches, that's a nice way to go from just the basic sine function to something that you're stretching. If I have the minus sine of 2x, I start out with my sine, so that's the normal one. And then if you remember, and most students remember the negative of the function as the parabola, x squared. If it's negative x squared, it goes upside down. I don't know, students always remember that. But what's happening here is you're reflecting it. So if you notice, if I'm multiplying by negative in this case, then these values are becoming negative. So where you see a 1 becomes a -1, where you see a -1 becomes +1. And then finally, when you have a number inside the function, if you remember transformations, this is a horizontal compression of a factor of 1/2. So again, you could see if I multiply each one of these terms by 1/2, that's where I'm getting my x value. So just a nice little way to think about when you have the graph of the sine function, the original one, and then go through transformations. All right, let's do the same thing with the cosine. So the cosine we know are the x values, trying to get something going on here. So I need to be looking when I look in the unit circle for the x values. So the very first thing I'm looking for is the cosine of 0. which I'm looking at the x values, so that would be 1. So my first point would be 0, 1. Again, I just picked some x values to be able to draw this out on a graph. Pi over 3, I can kind of go a little faster. I can see is 1/2, right? So pi over 3, 1/2, it's a comma. Pi over 2, looking at the x values. So pi over 2 and 0. 2 pi over 3, negative 1/2. 2 pi over 3, negative 1/2. Pi, I'm at negative 1. So pi, negative 1. 4 pi over 3, where you at right there? Negative 1/2. 4 pi over 3, negative 1/2. 3 pi over 2, 0. So 3 pi over 2 is 0. 5 pi over 3, 1/2. So 5 pi over 3, 1/2. And then finally back to 2 pi, which is at 1. So once again, I can come down and I can plot these. Now notice this one starts up at 0, 1. Then at pi over 3, it comes down to 1/2. Hey, don't do that. Comes down to 1/2. And then at pi over 2, it hits 0. Then it goes to negative 1/2, negative 1. So in other words, I'm right there. Back to negative 1/2. At 3 pi over 2, it hits 0, 1/2, and 1. So let me attempt to hit these dots here. So this is kind of, sort of what the graph looks like. Being an even function, I can do the same thing here. I can reflect these, so it's kind of nice to not have to go and actually find these values. And so back here, and so you can see that the cosine is a graph like that. But this one, the important part is that, remember the sine started at the origin 0, 0. This one actually starts up at the point 0, 1. And so remind myself, the domain, x values, all real numbers, the range, once again, I'm only going from 1 to negative 1. Symmetric to the y-axis since it's an even function. Okay, so that's my reflection there that I did to get my other point. Also, period of 2 pi, I can find my intercepts and my max and min values. I can look at transformations the same way. So there's a very nice, much better drawn cosine function. If I want to do 2 times the cosine of 3x, of course, the first thing I'm going to do is I'm going to do a vertical stretch by multiplying my y, my entire function, by 2. So everywhere you see negative 1, negative 2, positive 1, 2. And then I'm going to replace x by 3x. So this is my horizontal compression by a factor of 1/3. And so in other words, I'm taking 2 pi and multiplying it by 1/3, or dividing by 1/3, I should say. Same thing as flip, multiply, fraction. My pi, taking 1/3 of it, and so on. And so this is very important. I realize people use computers and everything, it graphs it for you and all that good stuff, but it's important that you understand the connection between this unit circle and what the graph of these functions look like. And we'll continue with graphs in the next episode.